So we're continuing on with our lesson 3.1, the last part, where we will graph y equals tangent x. This says the graphs of all tangent functions are related to the graph of the parent function y equals tan x, which is shown below. The function y equals tan x has the following characteristics. The domain is all real numbers, except odd multiples of pi over 2. Odd multiples. So that'd be 1 pi over 2, 3 pi over 2, etc. Right? There we go. So the domain is all real numbers except odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, etc. If you look here, this right here is 1 pi over 2, 3 pi over 2, 5 pi over 2, etc. That's where we have vertical asymptotes. An asymptote is a line that the actual graph will not cross. It'll get really, really close to it, but it will never cross it. The range is all real numbers. Okay, that's the output, the y values. So the function y equals tan x does not have a maximum or a minimum value. Therefore, the graph of y equals tan x does not have an amplitude because it goes forever in the y is infinity or y is negative infinity direction. The x-intercepts of the graph occur at x equals 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. Okay, so this is the parent function, y equals tan x. I forgot I put this in. So odd multiples of pi are values such as these. Plus or minus 1, plus or minus 3, plus or minus 5, etc. Alright, so characteristics of y equals a tan bx. The period and vertical asymptotes of the graph y equal a tan bx, where a and b are non-zero real numbers, are as follows. If you remember, this used to mean amplitude, and that we used to find the period. We still use the b to find the period, but the period is pi over b, not 2 pi over b. That's the difference with tan x. The vertical asymptotes are at odd multiples of pi over 2b. So vertical asymptotes, odd multiples of pi over 2b. Okay, let's see what that really means. Key points we graph with these. Now the graph at the right shows 5 key x values that can help you sketch the graph of y equals a tan bx for a is greater than 0 and b is greater than 0. So our 5 values are the x-intercept, the x values where the asymptotes occur, and the x values halfway between the x-intercept and the asymptotes. So at each halfway point, the function's value is either a or negative a. So that would be that one. Right? That would be a, let's see what I can do here, a and negative a. Cool? So 5 points. I've got the asymptotes, the x-intercept, and the a and negative a. Let's try one. Graph one period of the function y equals 2 tan 3x. So here I have a equals 2 and b equals 3. So I know my period is pi over b, so pi over 3. Our intercept, oops, sorry. It's going to be right through the origin. The asymptotes are x equals pi over 2b. So that gives us pi over 6 and negative pi over 6. And then we have the halfway points. Right now we have 1, 2, 3. 1, 2, 3 points. We need the other 2 points. So the halfway point are going to be at an ordered pair. So I need an ordered pair of pi over 4b, which is halfway, a quarter, right? Comma a. And pi, negative pi over 4b, so it's the other halfway point. And halfway between is going to be a quarter, right? Comma negative a. We know b equals 3, so I've got pi over 12, comma 2, and negative pi over 12, comma negative 2. So 4, 5. So jot these down and let's graph it. So I know highlight this, x-intercept is 0, 0. My asymptote is going to be pi over 6, and about there, negative pi over 6. Asymptotes, usually just as we practice, we'll get a dotted line up and down, just like you see. And then the last thing we're going to graph is the halfway points. So pi over 6, halfway between that is going to be, there we go, negative pi over 12, pi over 6 divided by 2, and positive pi over 12. So this is going to be, sorry, I'm having trouble with my pen, negative a, where a is, I lost it, 2. So negative 2 and positive 2. So there and there. And then we can sketch our curve. We're going to run right along the asymptote, through, and then up. Okay, that probably could have been better. Okay, I have 4 practice problems I'm going to work through. Okay, it's good to practice a few more than just that one. So here I have, and yes, it's graphed in the middle, but we're going to figure out where we get all those points from. A equals 3 and B equals 1. So first let's figure out the period. Period is pi over B, which in this case is 1. So our period is just pi. At this point I'm going to remind ourselves that that period is beginning to end, right? The whole thing. Pi equals period. Cool? Alright, go back to my black pen. What else do we need? We've got our intercept, which is 0, 0. Our asymptotes. X equals pi over 2b, so that's just going to be pi over 2, and negative pi over 2. So that gives me this line. So these are we've got 3 points. Now I need the halfway point. So I need halfway between 0 and pi over 2. That's going to be pi over 4b, comma a, is pi over 4, comma 3, and then negative pi over 4b, comma negative a. So that's going to be negative pi over 4, comma negative 3. So there and there. And that right there gives me enough information to graph my tangent curve. Just one period of it. Okay, here we have a equals 1, b equals 2. Our period is pi over b, which is pi over 2. So that means this whole distance is pi over 2. Our intercept is 0, 0. Our asymptotes, oops, they are x equals pi over 2b, because it's halfway. So that's going to be pi over 4 and negative pi over 4. So we have negative pi over 4 and pi over 4. And then our halfway points. I've got pi over 4b, comma a, and pi over 4b negative, comma negative a. So b is 2, so we've got pi over 8, comma 1, and negative pi over 8, comma negative 1. That gives us that point and that point. We have enough to draw our curve. Alright, I think we're good. You guys want to go ahead and start your work?